Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil Idhamil Mustafa. Okay, today our group will present you about our engineering mathematics 4 subject. Okay, before that I would like to introduce you our group project name is application of numerical integration for area of G3 lake. Okay, next I would like to introduce you our background of the project. Okay, as we know, in science and engineering, we set up experiment to obtain information or data, test hypothesis, make comparison between theory and practice. Although the outcome is expressive, experiment usually involve a lot of equipment and facilities, which are expensive. Thus, science and engineering are also solving the problems by using simulation. Therefore, this report is prepared to understand process involved, including the calculation by creating our problem statement, which is classified in environment engineering area. The problem statement, in this project we modified the experiment from our hydrology project work. Calculating the stream flow. In order to find a stream flow, there are several producers that need to be done, including finding the cross-section area of the lake. In terms of application in numerical method, we are using numerical integration, which focusing on Simpson rule by calculating the cross-sectional area of lake. There are two rules that we comply in our project calculation, which are Simpson 1/3 rule and Simpson 3/8 rule. Okay, for our project, we have three objectives. For the first one is to review the book related to numerical method in civil engineering. Second is to learn how to use numerical integration, which is Simpson rule method in order to calculate the cross-sectional area. And for the last is to list out the failure table related to the solution of the project.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Ahmad Hazim bin Ahmad Firdaus. I want to share with you about how we using the topic in Mathematics Engineering 4 for our project. And in this project, we are focusing on Chapter 6 from our syllabus of Mathematics Engineering 4, which is about numerical integration. Numerical integration is the approximate computation of an integral using numerical techniques. There are many methods available for numerical integration, and the most straightforward technique uses the Newton-Cotes formula, also called quadratic formulas. So, we are using Simpson's rule method, which is one of the Newton-Cotes formula for approximating the integral of a function using quadratic formulas. So, in our failure table information, first facts that the width of the lake is the value of interval of AB, which is A is x naught and B is xn, which is the end of interval. So we identifying the interval of integration and action stretch, we using measuring tape of the to measure the width of the lake. So second fact that the interval AB from the width is variable for each segment. So we're using H and we calculate the H for equal width, and then for our action we calculate by using the formula. So number 3 facts, the depth of the lake is the y-axis of the graph. So we're collecting data for calculate the cross-sectional area and measure the depth of water using the using pole. And lastly, we calculate the cross-section area of the lake by using the Simpson's rule of 1/3 rule and 3/8 rule Simpson. So we calculate and applying the formula into our calculation.
For our calculation, we solve this problem by using numerical integration, which is 1/3 Simpson rule and 3/8 Simpson rule method. Before we make the calculation, we need to know the depth and the width of Lake Q3. First, we wear PPE and inspect the work area that we want to use, and stretch the measuring tape from right to left water edge tie up the thread into pancang and put at the edge of lake. Mark each point on the thread 4 meter equally. Measure depth of water each point using pole. This is our drafted figure. We divide into 15 subsections. This is the depth and the width. Okay, for our calculation, we use 1 over 3 Simpson rule first. From 0 to 24. The value of n is 6. So we calculate 0 until 6. We put the width and the depth for start, odd, and even. And this is the formula of 1 over 3 Simpson rule. So we insert the total value of FO, F0, F6, F1, F3, F5, F2, and F4. This is even, odd, and start and end. So we get the area is 30.16 meters square. For 3 over 8 Simpson rule, from 28 to 60, the n value is 8. So from 0 to 8, we insert the depth to 2.1 for start, odd, and even. So this is the formula for 3 over 8. And then we insert the total for each start and end, odd, and even. And we get 46.425. Thus, the area of Lake Gigi, we sum up the total of 1 over 3 Simpson rule and 3 over 8 Simpson rule. We gain the area is 76.585 meters square.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Herudin bin Kasim. So I will explain on the discussions and conclusion for our group. So for discussions, throughout this project, our group decided to gather information ourselves online due to pandemic of COVID-19. This has taught us on how to build a teamwork can be done on a long distance. The use of social media such as WhatsApp, Google Drive, Google Meet, and also learning software such as Edmodo. The continuation of our previous project in hydrology also helps us to continue furthermore on the importance of numerical method in engineering. Although it is a theory, but it can be applied in our findings. Every calculations and methods were being considered responsibly with the supervision of our lecturer, Dr. Emidia. Because of the circumstances of long-distance teamwork, each of us were given a specific task, that is to restudy the findings of our previous project and improvise with numerical method. These are to ensure the legitimate numerical method can be applied towards engineering. We are then resulted the expected outcomes, that the numerical method can be applied in order to determine the discharges and the stream flow of a water body. For conclusions, as the conclusion, this project has achieved the objectives, which is to determine the velocity rate of water flow using numerical methods such as trapezoidal rule, Simpson 1 over 3 rule, Simpson's 3 over 8 rules, and Gauss quadrate. The total of velocity rate of water flow is 0.019 meter square negative 1, while for the total discharge Q is 0.3813 meter cube per second. Next, this project also has succeeded with the third objective, which is to obtain the profile of lake by collecting the data of the depth, area, and velocity. Furthermore, the method used for this project is to use Gauss quadrate and Simpson's rules, which are easier to calculate it, and the data is approaching accurate. In addition, current meter users are very good and give advantage as it can save our time and also has been set to measure water flow velocity. Thank you.